The last section is factoring differences of squares. So in the first one, we noticed the first number was a perfect square and the last number was a perfect square. And so the question is, if that happens where there's a different sign in between. Can you see that my first number is x times x and my last number is 3 times 3? Or I could have 4x squared minus 25. Now technically, you already know how to factor these, but they look different because it's just two things. If I wrote x squared minus 9 as x squared plus 0x minus 9, what would have to be first to get x squared? X and x. What are possibilities for the last ones to get 9? Could be 9 and 1 or minus 3 and plus 3. If you don't have something in the middle, it's like there's a 0 x's there. Can you see if I put plus 3 and minus 3, that your outside, which is 3x, and your inside minus 3x would just cancel out, and there'd be nothing left? Yes?
So we need to factor a binomial.
You can assume there's a 0x and make it a trinomial, but truly it is a binomial. Now this pattern only works if the first number is a perfect square and the last number is a perfect square. Because what we need is we need our outside and our inside to always cancel out. And if our outside and inside cancel out, they'd have to be the same. The only way they can be the same is if you have the same first number and the same last number, and one being positive and one being negative. So let's look at this one over here. I can make the first one's the same because that's a perfect square, 2x and 2x. I can make the last ones the same because 25 is a perfect square, 5 and 5. And if one of them is positive and one of them is negative, let's check what happens with our outside and our inside. If you multiplied this out, can you see that the outside would be minus 10x, the inside would be plus 10x? They would go away. And so because you are not used to going, oh, I'll just go and change this to plus 0x, okay? As mathematicians, we describe this and we give it a name. This type of binomial is called a difference of squares. Use the word difference because there's a minus sign in between. This type of factoring doesn't work if it's a sum of squares. It only works if it's a difference. And squares means that the first number and the last number has to be a perfect square. So how do we notice this? Well, you recognize a difference of squares when there are only two terms, in other words, a binomial, both of which are squares that are being subtracted. Can you see that these are all difference of squares? The first ones are all perfect squares, the last numbers are all perfect squares, and the middle is subtracting a difference. If that's the case, they are really easy to factor. One's plus, one's minus. And it doesn't matter which you make plus and which you make minus. 121, difference of squares, x, 11, and 11. One's plus, one's minus. Yes, 11 times 11 is 121. X, 6 and 6, one's plus, one's minus. If you quickly multiply all of those ones on the right-hand side out in your head, you will see that they simplify perfectly to be what's on the left. There are another 5 for you to do. Were you able to get 3x plus 12 minus 12?
Yes.
Good. Did anybody see that this one wasn't done? There's a common factor in here. You could pull out a 3. There's a common factor in here. You could pull out a 3. If I pull out a 3, that gives me x plus 4. And if I pull out a 3 out of the other one, it gives me x minus 4. The best answer for this one is 9x plus 4, x minus 4, which means that, and this is hard to see, there's a 9 in common in both of these to begin with. Do you remember the trick to finding out if something's divisible by 9?
If it adds up to something that's divisible by 9.
That's right. So 4 plus 1 adds up to 9. So we know that that's divisible by 9. So the best way to do this one, this isn't wrong, what I've done in black, but the best way to do this one would have been able to notice that first. Oops, not 6. 9 times 16. And factor that out. And then this is still a difference of squares inside, so x plus 4, x minus 4. So the green, I would say, is preferred, okay? But I can really understand why you guys wouldn't have seen that in this case, because you've got difference of squares in your head, which makes you think of one way over another way. If that happens, though, we always look for common factors even after we're done factoring. The next one doesn't have any common factors. It'll be 5x and 5x, 7y and 7y, 1 plus, 1 negative. The last one, can you see that there is a common factor in here? What can you pull out of both of those? So I'm going to do it the way that you did it. How many people did this first? 10a and 10a, 8b and 8b. 1 plus 1 minus. How many of you did that first? Okay. So if you did that first, then you'd have to say, ooh, I can still divide these by 2 and these by 2. So to factor it completely, oops, take out 2 out of the next one. And then 2 times 2 is 4. Had you noticed right away that there was a common factor? You can divide them both by 2 and then realize, oh, I could divide them both by 2 again. You could have pulled out a 4, making this 25a squared minus 16b squared, 5a plus 4b, 5a minus 4b. The next one, you have to see that you can pull out a common factor, because 500 isn't a perfect square, and 5 isn't a perfect square. But if I take out the 5, I will get x squared minus 100, and now the inside is a perfect square, x plus 10, x minus 10. My question on the last one is, did anybody do it completely? Is this a perfect square? What times what is x to the 4? x squared. Good. So you would have x squared and x squared. Is 1 a perfect square? Yes. So you would have 1 and 1. And 1 is plus, 1 is minus. We have another difference of squares appear.
A 1.
So this one you can't do anything with because it's not a difference of squares. But this one is x times x is x squared. 1 and 1. 1 is plus, 1 is minus. And now we're done factoring. I could have made it even bigger. I could have started with x to the 8 minus 1. Because then you would have x to the 4 and x to the 4. And the x to the 4 would have x to the 2 and x to the 2. And the x to the 2 would have x and x. Right? Or I could start with x to the 16 or x to the 32 or...
Can I put a cheeky question like that?
Cheeky question. Yes. And the last one is a fill in the blanks. Determine the missing factors. Can you recognize this, the right side, as a difference of squares? So if it's a difference of squares, then this would have to be 2a plus 5. All right, there's your homework. I do have a worksheet for you as well.